from the base of a building. The angle of elevation, this is the angle of elevation, is 38.7 degrees. They want us to approximate the height of that building. Can anyone tell us what to do? Very good. Yes, indeed. Tangent 38.7 degrees equals? Good. Cross multiply. X equals 30 times tangent 38.7 degrees. Put it in the calculator. So 30 multiplied by tangent 38.7. Close the parenthesis. Make sure again that you're in degrees. The mode is in degrees. Yes, it is. So I press enter and I have roughly 24. And that was, everything was in, So it says from a point on the level ground, 30 yards, okay, approximate the height of it to the nearest foot. Okay, so this is in yards. So x equals 24.034 yards. Okay, now we have to change this into feet. I'm looking to see anybody who remembers how many feet in a yard. Okay, then. Are you sure? Oh, 3, not 30. I thought I heard 30. Okay, so 3 times 24, 72 feet. Okay, 5.8. Moving on. Chapter 6. In Chapter 6, we only looked at, I'm looking back to my syllabus, so 5.1, 5.2, 5.8, 5.3, 5.5, 5.6, 6.5, just 6.5. Very good. Okay. A representative equation, problem 12, on page 694. On 694, cosine x equals the square root of 3 over 2. I see cosine is positive. I look at the unit circle and I ask myself in how many quadrants I will find angles whose cosine is positive. And which are those quadrants? Very good. So here and here I have to find an angle x, whose cosine, this is the cosine. It's measured on which axis? Very good. This piece, oh, I thought I used a different color. This piece is cosine x. And it's the same for this angle, and the same for this angle. Now I have to ask myself, and I remember that little chart, 1/2 the square root of 3 over 2, square root of 3 over 2, 1/2 the square root of 2 over 2, the square root of 2 over 2. Which angle has cosine the square root of 3 over 2? Pi over 6, excellent. So then x is, so I know the reference angle for sure. RA is definitely pi over 6 for both angles. This is also RA pi over 6. So the first angle is, first option is pi over 6 plus any number of rotations in any direction. 2 pi k, and I have to explain what k is. K equals 0, plus or minus 1, plus or minus 2, and 3 dots. What is the other option? From 2 pi, I come back pi over 6. You just calculate it on the side. 2 pi minus pi over 6. I need to multiply this by 6. 12 minus 1 is 11 pi over 6. So the other answer is 11 pi over 6 plus 2 pi k. Now the last two sections, 7.1 and 7.2, we just looked at a function, at an example with law of cosines. Let's choose an example with law of sines. Let's say I like to look at a word problem. I think we did 49. Let's do 50. On page 711. A surveyor needs to determine the distance between 2 points that lie on opposite banks of a river. The figure shows that 300 yards. Did we do this problem? We maybe did. Maybe
beach.
not this one. Okay, very good. Because I'd rather do another problem, not the same one. Okay, so they say 300 yards are measured along one bank. The angles from each end of the line segment to the point of the opposite bank, 62 given to us, 53 given to us. Find the distance between A and B to the nearest tenth of a yard. So they're asking us to find this. Maybe I should denote it by lowercase c because it's the opposite of angle C. So this is little c or x, and this is little a. So, law of sines, please. So, sine 62 degrees over, good, sine B over, and sine C, sine 53 degrees over or x. Okay. Now, I noticed one thing, that since I have two angles, I definitely have the third one. So this B is not an unknown. So this is nothing else but 180 degrees, minus 62 degrees, and minus 53 degrees. So then this is 65 degrees. So from this proportion, I have this, I have this, and I have this, and I can determine x. If I have two variables, I can't find what I'm looking for. But I have law of cosines, and I may use that. So then 300 cross multiply, 300 times sine 53 degrees equals x times sine 65 degrees. Therefore, x equals 300 sine 53 over sine 65. So then x will be approximately, I'll put it in the graphing calculator, of course, and I have, let me clear all this, and I have 300 in parentheses, 300 sine 53 and divide by sine 65. Okay. The mode is still in radian, in degrees, yes. So I got 264.4 approximately. And the measurement unit was in yards. I can't think of anything else. This is the entire test. And of course, the offer is valid. You can, I'm not finishing. I just don't want to work on problems. I just don't want to forget to tell you that the offer remains. You can start at 4:30 or 4:15-ish or whatever you want to do till 6:30. For those of you who came in late, let me say one more time, the final exam, write it down. So these are the options. One more time. 5 to 7 on Monday, 3 to 7 on Tuesday, and 3 to 7 on Wednesday. Beyond Wednesday evening, if somebody misses the test, the final exam, I have to calculate the grade with a 0. Okay? So write this down. Okay, now I will go back to any type of problem that you think you may have difficulties with. Yes, please. Charles?
When going back and forth in mode and changing it from radian to degree, which types of questions, just because I get confused, do I add degrees for versus radian?
So you're saying what type of problem would you need degrees, and which type of problem you would need
like
radians?
Yeah, for me to remember.
If you want to check, for example, let's say you're asked to find tangent of 405. Thank you. And don't forget about the session on Friday. So if I'm asked to find tangent 405 and I want to check, I already got the answer, but I want to check, then I have to have the mode in degrees. If I'm asked to find cotangent of 7 pi over 4 and I want to check with the calculator, then I'll have to have the mode in radians. If I want to determine an angle and I apply cosine inverse to 0.33, if I want the answer in radians, then it will be a little bit more difficult to figure out what it is. So I recommend put it in degrees so you can find out 25, 30, whatever it is, degrees. So it depends on the problem, actually. Okay. Is there anything that you would like to go back and redo other problems or think about other problems? Any particular type of problem? Okay, here's a problem, a word problem, if you'd like, if you don't have something for me. But I'll wait. I'll wait if you have something.
No, I'm trying to figure out where it was in the.
Okay. I'll copy a figure from your book on 57, but I want you to find what you're looking for. And we'll go back to that. 57 on 712. Redwood trees in California's Redwood National Park are hundreds of feet tall. The height of one of these trees is represented by h. Use the measurement shown to find A to the nearest tenth of a foot, and use the right triangle shown to find the height of the nearest tenth of the foot of a typical redwood tree. So first they're asking us to find A, and then they're asking us to find h. Michelle, did you find it?
I did.
Okay.
Well, I can wait until after this.
Yes. Okay. I just wanted to know.
Yes,
what.
I did.
Okay, perfect. So we want to find this. We know this angle. By the way, do we know this angle? Yes, because it's 180 minus 44. Indeed, 136 degrees. Do we know this angle? Yes, because it's 180 minus 37, so angle C, this piece here, is 180 minus 37 and minus 136. How much? 17? 70?
No, just 7.
I thought you said that. Okay. Good, so we have all angles, 37, 136, and 7. And we have this piece. It's given to us 100 feet. Can I determine A? How? Sine 7 degrees over 100 equals sine 37 over A, and I don't care for the last one because I already have law of sines for that allows me to determine A. Cross multiply. A times sine 7 equals 100 times sine 37, where A equals 100 times sine 37 over sine 7. Are you in agreement with this? So 100 parentheses, I like parentheses about for the top and parentheses for the bottom, times sine 37, close the parenthesis, and again for the top, and divide by sine 7. So I got that A is roughly 494. I will say A approximately 494 feet. Okay, now knowing the hypotenuse of this, knowing this angle, is there a way of determining the height? Which trig function will be, yes, do you all agree with sine? It's h over 394. So sine 44 is h over 494. Cross multiply. H equals 494 times sine 44. Again, I'll put in the calculator. So I can multiply the answer that I have multiplied by sine 44. And that will be the best approximation. 343. So the height of the redwood, 343 feet. Yes, any questions on this? Pretty straightforward. Okay, Michelle?
Just a refresher, it's page 560 and 17 through 22, any one of those.
You said 560 and it's
17 through 22, any one of those.
very good. 560. 580, 560. 17 through 32. Yes, I picked 26 just a few minutes ago. We do 26.
Like, so 17.
Yes, let's pick from that too.
Okay.
So 17 through 22, let's say 20. We are told that tangent theta is less than 0. We are told that sine theta is less than 0. We're only asked to find the quadrant. That's all we're asked in 17 through 22. So I go back to the unit circle. And where is sine negative?
3 and 4.
Very good. Done with this. Where is tangent negative? And the answer is, you told me not to remember that. Yes, that's true. But I know tangent will be negative when the signs of sine and cosine are opposites. Because positive of a positive will not be negative. Negative of a negative will not be negative, will be positive. So tangent is negative in 2 and 4. And it's positive in 1 and 3. So the other condition is fulfilled here and here. I can only choose the quadrant in which both conditions are fulfilled. Sine is negative and tangent is negative. Therefore, I'll say theta in the 4th quadrant. Is there anything else you would like to go back to? It's time for me to take my attendance then. I remind you, if you can, to fill out the opinion forms. I get an email every day, and I'm sure you get an email every day in your inbox, in your MyACC account, if you look. Any type of problem you would like to review? Any type of problem that you think we need to go back to?
Can we do another one of those
Right.
triangles that we just did before this?
Yes.
Graph is the triangle inside a triangle. I don't even know what she just did. I mean, that, the one that you just did. So page 712.
712. 712.
Like something like 57, you know, where you have.
Very good. 712, you said? 57?
That's the one we just did, so
Yeah.
something similar to that.
Okay. Which one?
Number 58.
58. Very good. So let's look at the figure at the top. .58 on 712. The figure at the top of the next page shows a cable car that carries passengers from A to C. Nice. Okay. Good. Point A is 1.6 miles from the base of the mountain. The angles of elevation from A and B are 22 and 66 respectively. Perfect. Determine to the nearest tenth of the foot the distance covered by the cable car. So the cable car covers this distance. Part B. Find A. No. Okay. Yeah. Okay. Yes. This is A. I did not denote that. I thought I was reading from the previous problem by mistake. Find A to the nearest tenth of the foot. Okay. And use the right triangle to find the height of the mountain to the nearest foot. Okay. Tenth of the foot. Very good. Since we know 66, we know this angle. Yes, it's 180 minus 66, 114. Good. So I know this. I'm trying to find B, and I know this, and I know these three angles. So then I also know 180 minus 136. Right? 3 from 7. Right? Am I correct? Good. So then I can write in this triangle, I can write law of sines. Sine 22 over A equals sine 114 over B equals sine 44 over 1.6. This is the only proportion that has B in it and just that variable. So then I'll cross multiply. 1.6 times sine 114 degrees equals B times sine 44 degrees, where B is 1.6 sine 114 over sine 44 degrees. Put in the calculator. So 1.6 times sine 114 and divide by sine 44. And I got B, the length of the cable car, or how far it goes from A to C, 2.1 miles. So B equals 2.1 miles. Okay, now I have this, which is 2.1 miles. Therefore, I can look at this triangle, possibly, and find, actually I can't, because let me see, I don't have this portion. So now I have to look at back here and try to find in this triangle Or just back to the same triangle, actually, it's even the best. It's the best. So go back here and just find A. So now I can use this. That's the best thing to do, not complicate things. So then 1.6 times sine 22 degrees equals A times sine 44 degrees, and A equals 1.6 sine 22 degrees over sine 44. How much is A approximately? 0.9? Okay, miles. Good. So now I have A. If I have A, which is 0.9 miles, I can easily determine the height from the right triangle because I have this angle. Which trig function I apply to determine this if I have this? Sine. Sine 66 degrees equals h over 0.9 over 1. When I cross multiply, I get h equals 0.9 times sine 66. And then will be the, how much? 0.8 of a mile. Any questions? They are asking us to find I think they are asking us to find it in feet. So I just want to check 1.6. When you multiply by sine 22 and divide by sine 44. Yes, yes, 0.9. Very good. And the other one I multiply by sine 66. Yeah, 0.8. Very good. Any questions?